Hey everybody, it is math in a matter of minutes. I'm going to do a little recap video on what we learned today. This is the final section in our unit, and tomorrow we will be testing, so I wanted to do a recap and then a test prep video as well. So for today, we worked on, it says, how can you use comparisons of fractions? Comparisons of fractions to order them. So we expanded on what we had learned on yesterday, which was comparing fractions using symbols. So for example, we have 1/2 and 3/8. The student should be able to use symbols greater than, less than, equal to, or not equal to. They should be able to compare two fractions using these symbols. This is what we did yesterday. They were taught many different strategies, and I want to go ahead and recap those with you. I'm looking for a marker. Here we go. And here we go. All right, so we have one of our strategies, which is the area model. We draw it out. This strategy is something that the children need to be able to know how to do for this unit. It is part of their standards. They have to be able to know how to do this. So this is halves, and this is eighths. So we need to color in 1/2 and color in 3/8. And then we need to compare them, and I can see that 1/2 takes up more shaded space than 3/8. So my open part would face the bigger number. We always say the alligator's hungry. That's one of the strategies. Another strategy that the children were taught were common denominators to solve this. So I have 1/2 and I have 3/8. I would think to myself, 8 is equal to 2 times what equals 8? That tells me what I'm multiplying this this fraction by to make an equivalent denominator or equal denominator or common denominator as we call it. Well, 2 times 4 is 8, so I would take 1/2 times 4 over 4, which equals 4/8. And now I can compare 4/8 and 3/8. Once we have that, we no longer need to worry about our denominators because they're the same. We look at our numerators to compare. And 4 is greater than 3, so 1/2, because that's where this 4/8 came from, 1/2 is greater than 3/8. That's using common denominator. So this is area model, this is common denominator. We also learned about, some people call it the butterfly model, some people call it cross multiplication. I call it cross denominator multiplication. 1/2 and 3/8. We multiply each fraction by the opposite fraction's denominator. This is a 2, this is an 8. I multiply this fraction by 2 over 2. I multiply this fraction by 8 over 8. Once I do that, I don't need to worry about my denominators. I know they are equivalent. Associative property of multiplication states that 2 times 8 is the same as 8 times 2. I just need to then worry about my numerators. 1 times 8 is 8. 3 times 2 is 6. 8 is greater than 6, so 1/2 is greater than 3/8. This is cross multiplication or denominator multiplication or butterfly multiplication. It has its own little name. Everyone usually gives it something else. We also have number lines. You have to make sure that your number lines are equal in length, so they need to be the same. And we mark our number lines the same. So you see how I do it evenly like that. This one is 0/2 because we always start with 0. This is 0/8. This is 2/2 because that's one whole. Remember, fractions are part of a whole, so we only need to go to one whole. And this is 8/8. Halfway between 0 and 2 is 1/2. Halfway between 0 and 8 is 4/8. because halfway between 0 and 8 is 4. And then here, I already have 1/2, so I put that here, and I evaluate the distance to 0. And then here, I have 3/8. This is 1/8, 2/8, 3/8. This here, and I evaluate the distance to 0, and I can see that it is a longer distance from 0 to 1/2 than it is from 0 to 3/8. So these are the strategies that we did yesterday. The children were reminded about all of these strategies today, and I did add this strategy. I didn't show them this yesterday. I did add this strategy in. So we are talking about comparison of fractions, which is what we did yesterday, and we're adding the ability to order them. So fractions is our math. What we're doing with them is we're comparing them and we're ordering them. So a problem today was this. Don't mind all this stuff here. This is the problem. It says Jody has equal size bins for the recycling center. She filled 3/8 of the bin with plastic, 1/12 of the bin with paper, and 9/12 of the bin with glass. Which bin is the most full? So you can see, this is the teacher book, so you can see what it shows. And it's showing that they're circling what they know and underline what they're asking. Now, we don't allow the children to write in the books, but we do expect them to do the exact same thing in their notebook on paper. And if you look at their notebook, they did work on this problem today. So what do I know from the problem? What are they asking? And I usually start with asking because it's the last thing in there, so it's the first thing we remember. Which bin is most full? So which bin most full? You don't have to write in a complete sentence as long as you know. So that tells me I'm looking for the fraction that takes up the most space. This is me comprehending what this says, the fraction that takes up the most space. Now what do I know? I know that we have 3/8 of the bin with, 3/5 plastic. And you see how I write it very quickly. I don't have to worry about complete sentences. 1/12 of the bin paper. And 9/10 glass. And I know that I'm comparing because it asks for which one is most full. So that's another thing that I know. I'm comparing. Now, I can choose to use any of these strategies that are on this page to solve. I could do area model. I could do common denominators. Cross multiplication might be a little bit harder since there's 3 fractions. And I also can do number lines. So I am actually going to do number lines, and the reason I'm going to choose something other than common denominator. The reason why is I could make 5/10, but I can't make 5/12. So my denominators would get fairly large. It would actually be 60ths before I could get to compare them. So I will start off with showing you a number line. And I would need 3 number lines, and they would all need to be the same length. All right, so this one is my 5ths, 12ths, 10ths. They all have to start at the same 0 point. They all have to end at the same 1 point because a whole fraction. So 0/5ths, 0/12ths, 0/10ths, 5/5ths, 12/12ths, 10/10ths. So these all equal 0 and these all equal 1. Halfway between 0 and 5, well, I can't really do that, so I need to break this up into fifths. That's 1, 2, 3, 4. Looks pretty even, so I'm going to label it 1/5, 2/5, 3/5, 4/5. 12ths, halfway between 0 and 12 is 6, so I'm going to go right to the middle. Put 6/12ths, and then halfway between there is 3/12ths, and this is 1/12. I'm going to stop labeling there because I only need to go to 1/12. Halfway between 0 and 10 is 5/12. And I know I'm going to 9, so I don't need to worry about over here. And this one is 9/12, or 9/10, excuse me. I put 12ths, it should be tenths. And this is 9 because it's one more before there. So now I'm going to plot my fractions. This is 3/5 right here. So I'm looking at the distance from 0 to 3/5. 1/12, the distance from 0 to 1/12. 9/10, the distance from 0 to 9/10. So now when I look at my numbers and I compare my fractions, I can see that 9/10 has the greatest distance from 0 to 9. And that is, let me see here, which bin is most full. So the answer would be the glass bin is the most full of the 3 bins, period. So this is a typical word problem that the students would have to do when it comes to comparing and ordering fractions. They could have also drawn out the area model, which I will do as well, to just help you see what they're doing. Here's 3/5, 9/10, and 1/12. So I can see the same thing here. It looks exactly like this, except it's not in a number line, and they're right there. Any of these can work. I will show you with common denominators. So I take 5, 12, and 10. I can't multiply anything times 5 to make 12. I can't multiply anything times 10 to make 2. So I have to think about it in the term of multiples. And the reason why I wouldn't go this route at first is it is a little more work to go. So here we're doing multiplication and it's 5 times 1 and then you write the answer here, or it's pattern of 5, 5, 10, 15, and you would get all the way to 12, which is 60. 12 times 5 is 60, and 10 times 6 is 60. So I would take my 3/5 and multiply that times 12/12, which equals 36/60. 1/12 multiplied by 5/5, which equals 5/60, and 9/10 multiplied by 6/6, which equals 54/60. And now I can look at just my numerators, 36, 5, and 54. 54 is the greatest, so 9/10 would be the bin that is the most full. So this shows you all of them. The students were to do this today. We did practice on it. We did have some students get the exit ticket not correct, so I want to go over that as well. The exit ticket states, I'm going to put it up here so you can see it. A recipe for trail mix includes 3/10 cup of sunflower seeds. I write down what I need. I'm going to put SF seeds. 1/2 cup of raisins. And 3/8 cup of granola. Which list shows the amounts from least to greatest? So now that I've read the problem, I need to write down what I know and what they're asking. What do I know? What are they asking? They want it from, make sure I get that right. And this is, if the students got it wrong, this was the reason. Some of the students got it wrong because least to greatest. they put it in the wrong order. And unfortunately, with me right now, I'm able to explain to them and say, you need to go back and look at the problem. You answered the problem, you showed your work, but you did the problem wrong. Go back to what they're asking. But on FSA, we can't do that. So what do I know? 3/10 sunflower seeds, 1/2 raisins, 3/8 granola, and from least to greatest. All right, so I'm going to do this here. I'm going to do area model for this one. Yeah, and the reason why I'm not going with common denominators is I would have to go to 40 for this to work. 10 times 4, 2 times 20, and 8 times 5, and that gets really big. So I'm going to go with area model. Any of these strategies would work. A number line would work. Area model, common denominators. I just want to go with the one that's the easiest for me. All right, 3/10, 1/2, 3/8. So now looking at this from least to greatest, this is 3/10, 1/2, and 3/8. The least would be 3/10. The greatest would be 1/2. And the one in the middle would be 3/8. So this is how they should have answered this problem. That's what we worked on today. So not only were we comparing them, which was building on what we did yesterday, but we also went to putting them in order based on a certain direction. I hope this video helps everybody. Thanks for watching. Again, this is a recap on comparing and ordering fractions.